later. So welcome everybody. My name is John, and today what we're going to go over is Sumo Security User, how to utilize Sumo Logic to go through some security use cases. We'll be doing some lab work today, but I just have a slide or two just to kind of set the stage, and then we'll dive into the work. So what are we going to be talking about? What are we talking about? We refer to security analytics. And so what we're talking about is the ability to give you and your users insight in real time to information that might be helpful in compliance and security use cases. And we have a couple of bullet points here, such as meeting compliance deadlines, reducing security risks, etc. You're probably very familiar with those things you need to comply with if you're in a security role. We'll also talk about some automated threat detection that can occur. So how you can start to detect threats across microservices and other environments as well. So we'll go through some of those tools and show you how to do it. Pretty straightforward. And then what are we talking about when we talk about some examples of security use cases? We'll do a couple of these today. What we're going to look at are, for example, the ability to monitor root logins. So you can take a look at users that are logging in, check to see if they have root access, and then decide should they have access to root. We'll do monitor multiple failed logins. We actually won't do that one. We'll actually do one where we monitor multiple successful logins. So kind of the same idea. You'll see a user that has logged in multiple places during a single period of time, and then it's up to you to decide should this user be doing that. So what we're going to be doing is giving you the tools, giving you the operator, the queries, helping you understand the ability for you to start to create a security, and we can let you know that we think an IP is malicious, but then you need to decide, do I want to block it on my firewall level? Do I want to let it through and monitor it? That's kind of what you'll have to do. So why don't we go ahead and get logged into the system? And to do so, we're going to use our training login. So if you've been with us before, you probably have used this login. If you haven't, go ahead and type it in. I'm just going to paste it into the chat as well. And so we'll log into this address, and or this site rather. And the username will be training+labs@sumologic.com. And then the password will be Sumo Labs, capital SUM0, capital LABS, exclamation point. So I'll give you guys a few more moments to log in, and then we'll go ahead together. And if you haven't used this environment before, it's going to be a really nice place for you to, for lack of a technical phrase, mess around in. It's a great place that has, it's a lab environment, or demo environment, if you will, although it is lab, it's production stuff. But we have some test data in there. And so you can go ahead and start to see what does it look like if I look at Apache data? What does it look like with O365 data? What kind of query can I make with this? And it really gives you a place to test those things. So you're welcome to use this environment after today. All right, I'm going to assume everybody's logged in. Like I said, I put the credentials in the chat. So if you need them, go ahead and grab them in there. I should also add, just in regards to chat, if you have any questions during today's session, go ahead and put them in the chat or the Q&A, and I'll grab them periodically and go ahead and answer them as they come up. All right, so now that we're logged in, you can ignore this secondary login, but now that you're logged in, you should be on a screen that looks very similar to this. I imagine everybody on this call has logged into Sumo Logic before, so we'll just continue on from here. So we're at the home page, and we're going to go straight to the Learn tab. Excuse me, we're going to go straight to the Certification tab. So Home, Certification. Now, in the past, this is where you've taken your exams, and you will do so later, but we're not ready to take the exam. Let's build up to it. And so what we're going to start with is the Sumo Security Power user on the far right, and there should be an option for hands-on labs. So we'll go ahead and click that, and then at this point, we should now have two tabs available, the Sumo Logic tab, and then a tab that has the labs in it. So I'll give everybody a moment or two to go ahead and do that. So just if you're joining us right now, as a reminder, the credentials are right here. Let me see, one user's having a problem with the credentials. Let me just go ahead and send them directly to him or her. And so these are the credentials we're going to use to log in. And then once we log in, we're going to go to Home, and to certification. And the chat is going to occur in the Zoom for those of you that might be having problems getting to it. Cool. So, and once we're in the security power user, then we're going to click on that hands-on labs, and then that's going to open up the labs. So we'll use the, like I said, 2 tabs, and you'll be using kind of a third view of the Zoom. So kind of a lot going on your screen, but we'll get through this together. So let's go ahead and get started here. So we're going to start with some basic labs. You know, it's a good place as any to start, and then we'll ramp up and get certainly more advanced. So some of this may be a little bit repetitive, but I think it's still worth going over. And we may skip a few things here and there. And I should mention about that. So what we have here now with the labs, we have about, I think about 20 labs now, 21 labs or so. Some of them have subsections, so there's even more than that. We're not going to go through all the labs today, both due to time, well, primarily just due to time. So any labs that we skip over, I don't want you to think that they're not important, just we only have so much time together. And so that's why we may skip a few here and there. But I certainly encourage you to go back and grab those at some point. So let's go ahead and get started here. So we're going to start with the, like I said, with the introduction, and we're going to start with lab 1. So we should be on lab 1, search basics, metadata, and keywords. And so I'm going to go ahead and do these on my screen. You'll do them at your device. I'll give you some time here and there, and you know, we'll just go through these. Once again, any questions, put them in the chat. And then there will be some labs where I may tell you to go ahead and do them, and so you can kind of get some hands-on experience before I ruin the surprise of what they do. So there'll be a few like that. But the first couple are, like I said, very straightforward, but they're good places to start. So what we're going to do here is we're going to go ahead and grab this query here and paste it into our query window. So we're going to make sure that we're at a new query window. So to do so, we'll either go to Home and go to Log Search, or go to the top of the screen. Let me get rid of all my other tabs, and go to New and go to Log Search. Same difference, but ultimately we're at the Log Search screen. So we're going to start and just paste this query in. And by doing so, we're going to specify the last 6 hours as well. So what we're doing here is we're searching for all messages for the last 6 hours with this source category that contains the word root. And we'll click Start. And so just as a reminder, what's happening here is we're going ahead and we're looking specifically at our AWS CloudTrail data. Within that data, we're specifically looking for the word root or the string of root. And we're doing so for the last 6 hours. So data that has time stamps or time information from the past 6 hours. And then we get our results down below. Now for this first one, you might be looking at these log messages, and here's each log message. And you might say, all right, well, it's great that, that you're looking for the word root. I see the log message, but I don't see the word root in there. Why is it being pulled as a result? And the reason is it's actually showing up under a nested field or a nested sublevel here. So here we have user identity, but if I click on this little arrow to expand it out, one of the fields in there is a type, and one of the values is root. So the system is finding that keyword of root or that keyword of root, either one, and then that's why it's being included in the results. So I just want to point that out. Now what we can do in step 2 is go ahead and use a wildcard here. So rather than just looking specifically at our CloudTrail data, we can go ahead and look at all of our AWS data that contains the word root over the last 6 hours. And so we could just put a wildcard in there. And the reason we're doing this is just to remind you that you can use those wildcards in the source categories as well as other places, and to help you start to look at a broader set of data without explicitly calling out that you want to look at CloudTrail data, you want to look at CloudFront data. Just say, I want to look at all my AWS data, and you got it. Now, the next portion that we'll go ahead and do here is introducing LiveTail. I've utilized LiveTail before. We do a lab with it, but I think it's good for you to see. So with LiveTail, what you have the ability to do is take your data and look at data as it becomes ingested. Because when I do a query like this for the last 6 hours, I'm essentially looking at old data. Now, old is a relative term, but it is data that has been ingested and processed through the system. But if I go ahead and go to LiveTail, what I'm now seeing is data as it becomes ingested into the system. And so essentially real time, data that has not hit any processing rules is just coming to Sumo Logic. Now I can go ahead and see that data, which can be very helpful in many use cases. With the live tail, you have the ability to use it within the app like I'm doing right here, or we have a command line interface that you can utilize as well. So if you prefer to use one over the other, you're certainly welcome to. It's basically the same thing as a tail-f function in a Linux Unix environment. So if you've ever used that, that's pretty much what this is. The one kind of warning I guess I would give about it, although if you've used it, you're probably familiar with this, is as you start to ingest data, this screen can get quite busy. Now in this case, I just have lab data, so we're only ingesting a couple records each minute, I think, on a second basis. But if you were to use this in the real world, this screen could start to look like the Matrix, and it can start to appear be just green letters flying by, and like I said, get very busy. Now you can pause it, you can search by keywords. I don't want to discourage the use, but I just want to mention that as a kind of a heads up. Some people will think that this feature is really helpful and that they love it and they're glad we added it. Other of you will just never use it again. At least now you know where it is. So if it's something that interests you, please use it. If that's no relevance to you, well, at least now you know where it is. All right, cool. So let's go ahead and jump to part two. I assume that's pretty straightforward so far. Now part two, we're going to go ahead and let's do this first query that's here. I'll go ahead. I'll start doing it. I want you to do it at your device as well. So to do this, we're going to do a new log search. We don't need that live tail anymore. And I'm going to go ahead and just grab the query itself. But I want to talk about the steps that are going on here because what we're trying to do and how we're going to accomplish it. So what we're doing here is the goal of this lab 2 is to search for our CloudTrail logs to identify the top 10 IP addresses for the US West region. And so when I read that, I like to think of it as almost as a word problem. And what are we trying to solve? And what are we going to look for? What are we going to tell the system? What do we need to tell the system to find? So by seeing this line here, I know, well, we need to look at the CloudTrail logs versus the CloudFront log versus the Apache log. So it's telling me what logs I need to look at. I know that I'm going to need to identify an IP address because that's one of the things we need to look for, the top 10 IP addresses. So somewhere in my query, I'm going to need to tell the system how to locate an IP address. I'm going to need to tell the system how to identify a US West region, which leads me to believe, and I know it as I go through the query, but it leads me to believe that I need to tell the system how to identify a region, and then more specifically, how to identify just the US West region. And then we want to look for the top 10 IP addresses, not all of them. So it's telling me that we're going to need to use a top or some sort of limiter to only look at a certain number versus a total number. So how are we going to create that query? Well, the query is down below, so there's not too much work you need to do on it, but how it works together, I think, is what's going to be helpful here. So on the first line, we're saying grab the CloudTrail data. The second line here, this is commented out. So as a reminder, you can comment lines, which means they turn them off and you can actually put notes in there. Now the third line here, or the second line of the query, is where we're going to start to grab those regions. So we need to tell the system how to locate a region, what a region is. And we can take advantage of the fact here that this data is in a JSON format. And if we go and just run for the CloudTrail data, we can see that. Let me clean up the screen just a little bit here. And so what we have in this data here is an AWS region with a value. But now we need to train or tell the system how to locate this AWS region and then the values associated with it. So how do we do that? Now, this is where we could go ahead and parse using regex. We could parse using anchors. We could parse using field extraction rules even. But there's another way to do it. So what we can do is, since this file is in a JSON format, and we know that because either we know that CloudTrail data is in JSON format, or we see the JSON word here, we can take advantage of the JSON operator. And so what we can do here is we can say JSON AWS region, which is basically saying go through the JSON or extract the values from JSON and explicitly only the one for AWS region. So now when I run this, I should now have a field for AWS region and values associated with that region. Now, we still need to tell the system to only look at those US West regions, and so that's what we're doing on this line. We're saying, show us only where the AWS region equals US West 1. So now when I start this, I will only have US West 1. There's only one region that's showing up as data. So that's good. I got the US West portion going. I have my CloudTrail data, but we still need to look at those top 10 IP addresses. So how do I go ahead and do that? Well, I need to locate an IP address. So here is an IP address, or here's the source IP address field, and here's the value, that IP address that I want to extract. Now, once again, there's multiple ways to do this. I could go ahead and use regex. I could go ahead and use the parse anchor. I could use this JSON here, but I'm going to use the regex. And the reason I'm going to use the regex here is just to show you that you can mix parsing operators in one query. So you can use JSON and regex as parsing in the same query, which is good, helpful. So with this line, we're saying use regex, use regular expressions to look for or create a field called IP address. And the way I want the system to identify IP address is to use the syntax of number.number.number.number. When the system finds number.number.number.number, it's going to identify it as an IP address. And that's why I have this IP address field here. Now we're going to go ahead and count those IP addresses because remember, we just want to do the top 10 of them. So we need to count all the IP addresses up. When we do count, we're doing math, we're doing aggregation, and that's why we have this results tab called aggregates that has the results in it. And as you can see, it has 25 pages. There's about 25 on each page. So there's what, about 600 results or so? Well, we only want the top 10. And so that's why we're going to use the top operator here. So we're going to say of the IP addresses, just sort them, grab me the top 10 and do it by count. And now when I run this, this count list will be sorted and we'll chop off the bottom 610 or so and just keep those top 10. Let's do lab number 3. And lab number 3, you may have seen some of these features before, but I think they're worth going through quickly as well. Yeah, they are. Just deciding there, but yeah, let's go through them, even if we do so quickly. So this is going to be lab 3, and what we're looking at here are a couple of options that we allow you to utilize when parsing is applied. So I'm going to grab the query here, and then I'll just talk about what this feature is doing. And parse out that, and parse out that. Okay. So we're looking at lab Apache error data versus Apache access data, which is what we kind of normally use, but this is error data. And what we see in here are the idea that there are clients and IP information here. So here I see an IP value. The next one, I see a client and an IP. Next one I do as well, but this next one I don't. The one after that, I don't. So some of these messages have a client and an IP, and some of them don't. If I tell the system to look for bracket, look for client, whatever's after that will be considered a client IP, the system's going to do what I tell it to. And it's going to see if there's an IP, and if there is an IP and value for the client IP, it's going to display that log message with the value. If there isn't a match there, it's going to just drop that message. So that's why we don't have any messages that do not have an IP, because those have all been dropped. Now, what if you want to see those? That's where no drop comes in. So with no drop, simply saying, show us all the results, regardless of if there is an IP or not. And that's what we're showing with this feature here. Now, we'll also have the ability to use the is blank option here, which is kind of going to show us the opposite, where we're saying, show us only those places where the client IP is blank. So a couple different options that can help you start to look through your logs and find things you need and see what's dropping as well. Let's see, I have a couple questions, so I'm going to go ahead and try and tackle them. So one question was about just recording the session. We'll be sending out an email with the recording at the end of today. So we got you there. And then let's see if I can grab this other question. Sorry about that. Let's see. Okay. So we can slow down a little bit as well. So that's the first example that we want to show with parsing options. The second one, why don't you guys go ahead and play with for a few moments. So this one, this is going to be lab 3-2, and so I'll give you a moment to play with it, and then I'll explain what we're doing with it. All right, so what we're trying to solve for here is kind of another word problem. And the lab actually displays what the problem we're trying to solve for is. So what we want to do is we want to identify the top 5 Sumo Logic committers in GitHub. And so what we need to do with that is we need to start to look for users. We need to define those that are a Sumo Logic user. And then we need to go ahead and just look for the top 5 of them. So how are we going to do that? Well, we're going to use the source category of labs GitHub and look for the word committer. And so what we're doing is we're pulling up some GitHub data. And within that data is the idea of a committer. So here's the committer, the individual that has committed code or submitted code. And we see information about that user. We see his name, his email address, his username. And so what we can do is we can start to extract his email address as a valuable piece of information. So we need to identify or tell the system how to identify this section as an email address. So how do we do that? So we're going to go ahead and use our parsing, and we're going to tell the system, look for the quote, look for the bracket, the word email, close quotes, the colon, open quotes, whatever's in there, that's going to be the field of email. So by doing so, we're now parsing out that field of email. So now the system knows what an email is, or more specifically, how to locate an email, where it is in the log message. Now what we need to do, though, is split this up, because we just want to look at the Sumo Logic users. And so what we can do is we can take the field of email and split it up even further into 2 additional fields, breaking it at the @ symbol, where we're going to say before the @ symbol, we're going to call that user or users. After the @ symbol, we're going to call that domains. And so what we're trying to express here is the ability for you to take a field that you have parsed and then parse it even further. So we're taking that field of email that we just parsed. Now the system knows how to find the email, and we're going to parse it out and break it out into a user and a domain. So now when I click start, I should have 2 new fields. I still have my email field, but I have a field now for domain and a field for users. Now the goal here was just to look for the top 5 Sumo Logic committers. And so what we can do here is we can say, only show us those users that have a domain that's equal to Sumo Logic. When we click start, our results are going to drop drastically, because now we're just looking for those users that have a sumologic.com domain or sumologic.com email address. And now we're going to start to count by users. So we start to see those users that have committed code, but now we want to count by them. So we want to take all those users that are left, add them all up, and now we see over the last 15 minutes, here are all the individuals that have committed code to GitHub from Sumo Logic. But we still need to look for the top 5. So once again, we're going to use that top operator to say, show us only those top 5 users. So take this list, sort it, chop off 2 of them, and we'll now have our top 5. Okay. So the next portion that we should go over is parsing multi. This is going to be helpful if you need to parse. Well, let's show you why it's going to be helpful. So what we're going to do here is we're going to look at some security data. So let's go ahead and pull up the set of data that we want to take a look at, which is going to be some snort data. And I'm also going to grab my regex, because I'm going to need that. Now, what we want to show here with this snort data is this is security data. It's not generated by Sumo. We're just ingesting it as a source. But what we have in this set of data is we have log messages that have multiple IPs. So each log message is going to have 2 IPs. Now, what those IPs are doesn't really matter for today. Let's assume they're kind of source destination, IP1, IP2, but we see them both in there. Now, if I tell the system to parse using the regex, using number to identify an IP address, the system's going to do exactly that. So it's going to say, can I find a value that's equal to an IP address? Yes, I can. The problem with that, and I guess it's not a problem, but just I want you to be aware of it, is it's going to try to match the pattern. If it can, it's going to consider itself done and then go to the next log message. So in this first message, it's going to look for an IP address, and it found 145.136.53. The second IP address of 10.224.171 is dropped because it matched the pattern with the first IP address, and it just goes on to the next log message. The next log message has this IP, 208.178, and there it is. The IP address of 10.224 is dropped once again. So what if you want to include those in your results? You want to see those IP addresses that are being dropped. What you can do, or not really being dropped, that's probably not the best phrase, are not being included because only showing the first occurrence. But what if you want to see those? What you can do is you can add the option at the end of the query line where you're parsing of multi. And what multi does very simply is it tells the system look for multiple occurrences. So go ahead and try to match the pattern of number, dot number, dot number, dot number. If you can, great. Go ahead and look for another number, dot number, dot number, dot number in your log query, in your log message. If you can find it, great. Look for another instance. If you can find it, great. Until you can't find any more, and then go to the next log message. So the way this produces the results, it's a little odd, but it's still here. Is the first log message has the IP of 145.136, and there it is. The second log message has the IP, or the first log message with the second IP is 10.224.171, and there it is. Next log message, the first one is 208.178, there it is. And the second one is 10.224.227, and there it is, and so on and so forth. So this is a way that you can go ahead and include multiple occurrences that match your pattern. The question that usually comes up at this point is, what if I want to go ahead and include both IP addresses in my results, but I want to treat them differently? I want to treat them as a source and a destination, or an IP1 versus an IP2. How do I do that? Well, this would be a good candidate for a parse. Because what you can do is you can use the UI to do this even, is highlight a portion of the log message using the TCP with the brackets as your anchor. So we're going to highlight it, and we're going to choose to parse the selected text. And then what we're going to do is we're going to say, okay, this first field here, we're going to call that source IP. This guy right here, we're going to take that, and we're going to call that source port. And then we're going to continue and do the same thing over here, but here we're going to call this, say, destination IP. And then destination port. Submit that. And now what I have is for each log message, once I run this, I'm going to have each piece of information in there. Actually, not going to, I don't need that. So we're going to have for each log message, we're going to have a destination IP, a destination port, a source IP, and a source port. And now you can start to do things where you compare them or whatever you might do with that information. But just wanted to point that out because that's a common question that comes up here. Now, the last thing we want to do with this lab 3 is go through the field extraction rules. You've probably seen these before, but they're also something that's worth repeating because the field extraction rules are just really important for you and your users. So let's go ahead and through this one, and then we'll get more security-minded in a moment. So for this step, what we're just going to do, it's really a quick option here, is we're going to go ahead and look at the data first. So I'm going to go ahead and pull up the source category of Lab Apache Axis. Now, I've pulled up the data. I haven't done any parse rules, but over here in the field browser, I have a bunch of fields associated with my data. I have a field for source IP. I have a field for status code. I have all these fields that reference my data, but I didn't create a parse statement to do those. And the reason it's here is it's taking advantage of field extraction rules. And what the field extraction rules allow you and your users to do is set up a rule that says when this data gets ingested, parse the data right away. So go ahead and, as this Apache data comes in, go ahead and identify where the IP address is, where the status code is, and turn those into fields that I can then utilize. And by doing so, I can go ahead and utilize them in my query, and I don't have to parse for them. So in this example here of this lab 3-4, we want to look for the status codes that are equal to 404. Well, I can go ahead and just very simply do status code equals 404 because the system knows what a status code is based on the field extraction rule and knows what those values are. And I can just say, show me those that are 404. And now when I do that, I get only those results that have a 404 in them. And I can also see that through here. So here's the status codes, and there are all the 404s. I can also do the count by source IP. So if I want to now count all these 404s by source IP, I can do so because same idea. The system is telling or labeling the data as it comes in and saying, look for the first thing in the log message, call that a source IP. And so now I can go ahead and count by source IP since the system knows how to find that. All right, good. So let's go ahead and start with lab 4. Let me get you guys started, and then I'll give you some moments to play with it. So to get to lab 4, we're going to go ahead and go to lab 4 in the tutorial steps. But we need to go ahead and open up a post that's located in our community forum. So if you go ahead and just click on the link for security-related queries for AWS, this should take you to what we need to use. And so what we have on this page are 3 different use cases, I guess we would label them as, that will allow you to do stuff with AWS data and the Sumo Logic query language. So the first one is going to allow you to look for root account usage. So using the query, you can go ahead and see which users have root, what they're using it for, and then as I described, you would put on your security hat and then just talk with them and say, should you have root access, or talk to their manager. So why don't you go ahead and start to but you do this first step, so this monitor AWS root account usage. So I would take the query, paste it in, and see how it works. And then I'll come back in a minute or two and go through it kind of line by line. The one that kind of, I guess, heads up I give you is the ARN is going to be the same thing as the user. So that's how Amazon expresses users. So when you see that ARN, individual or information, imagine that's a user. So go ahead and play with this for a few moments, and then I'll jump back in and walk through it line by line. All right, so let's go ahead and start to look at this query. So what we're going to do in the first line is say, look at our CloudTrail data, which is the data that's going to be relevant for this use case. And we're going to say, look for the word or the keyword root. And the reason being is we'll eventually look for root access, but we can use the keyword here to limit our result set so that we're only getting those things that might be relevant. We're not bringing in all AWS CloudTrail data. We're saying just bring in that data that has the word or string root in it. The next 2 lines, we're using the JSON operator to go ahead and turn the log messages into fields or grab the fields from them. So we're saying go ahead and look for that field of event type. Where is that? Somewhere in here. There it is, event type. Look for event name. Look for event source. Look for source IP, etc. We're going to go ahead and use this next line to do the same thing, where we're taking that field that has been identified as user identity and then looking for those subfields. So as I showed earlier, we're looking for this information in here. That's why we're doing another JSON. And so now when I run this as is, I should have about 6 or 7 fields created for me. So here I have a field for ARN, which is that username, the event name, so what the user was doing with that root access, and then some other stuff. I'm going to go ahead and limit my results to only looking for the type that's equal to root, because this will be an indication that the user has root access. So we're going to say just look for type equal to root. Because now the system knows what a type is, and now we can just explicitly say only show us that are root. So when I click start, the results are limited a little bit. They might not actually be, but it would limit them. Now this next line is a little bit of a weird line. It's really more of an AWS thing. What this is basically saying is where the source IP matches Amazon AWS, exclude those from the results. So there are some periods, I don't think I have any examples in here, where the IP address can actually show up as something .Amazon AWS something else. Certainly not an IP address, but it does show up in that field. So we're saying exclude those if that occurs. Now we're going to go ahead and just take the date information and just format it. So kind of organize it or clean it up. So take all this message time and that format and call it a date. And now we're going to start to count by those things. So we're going to count by the date, the event name, the event type, etc. And what this is going to show us then is what the users were doing and who they were that had root access. Now, as I mentioned earlier, this ARN is the username. So in this case, the user was 1, 2, 3, 4, 5, 6, 7, etc. And what we see is he or she, I guess, we don't really know the gender of the individual based on a number. And so what we can do here is we see that this user at 12:26 scheduled a key deletion from this source IP. He then did a start, or not necessarily in the same order, but then he did start logging, bunch of start loggings, bunch of scheduled key deletions, etc. So this is allowing us to see what the users are doing with that root access. And now this would be the spot where you would put the security hat and decide, should this user, should 1, 2, 3 be doing all these key deletions and start logging? I don't know. But hopefully someone in your organization does. So maybe talk to his manager or him or whatever and decide if he should not have this much access, remove it. If this is perfectly expected from this user, then all is well. If this user was on vacation during this period of time and you saw all these actions taking place, well, then you have another problem. So this is just kind of telling you what's going on and then with that information. Now the next lab we're going to do, I'm going to skip over this middle lab with the permit any ingress security groups, kind of just due to time. But this next one I do want you guys to go through. So what this allows you to do is to monitor a user's logins from different IP addresses. So to see where our user is logged in successfully from multiple IP addresses. So why don't you go ahead, same idea, play with this for a moment or two, and then I'll jump in and describe what it's doing kind of line by line. All right, so let's go ahead and go through this one. So the goal here is to monitor user logins from 2 different IP addresses during a period of time. So with the first line, once again, we're looking at that CloudTrail data, and we're looking just for console login. Same way we did last time, we want to use that keyword to just limit the results so we don't get all the CloudTrail data. We just get that which is relevant to our search. The next 4 lines or so are doing the JSON operator. So once again, taking that CloudTrail data and then pulling out the fields that are available to us. So now when I run this, I have the CloudTrail data and those fields kind of exploded out. Okay. Now this next line here, we're going to say, just show us where the console login is successful. Because in this example, we're just looking where a user has successfully logged in from different IPs, not necessarily tried. So this is successful attempts, not just, or successful results, not just attempts. So bit of a subtle difference, but just want to make you aware of that. So now when we run this, we should only get those where console login equals success. I don't think it's really going to limit the results too much. And now we're going to need to start to take this data and sort it. So at this point, we have information about those users that have logged in with a success, but we need to start to cull through it and specifically now look for logged in successfully multiple times during a time period. So now we're going to start to do some math with the count. So we're going to say take the ARN, which is that user information, and count it up with the IP addresses. We're doing count, we're doing math, we get the aggregates tab. And now what we see is this user has logged in from this IP address over the last 15 minutes. This user has logged in from this IP address in over the same period of time. And we're seeing the same user. But what we want is the system to tell us that this is the same user. So we still need to modify our query. Because now we're just seeing those users that have logged in successfully during the last 15 minutes, not necessarily those users that have logged in from multiple places in the last 15 minutes. So we're going to go ahead and sort by the user or by the ARN. Now we're going to do, it's kind of a little trick here, but it works out pretty well. We're going to start to label rows with numbers. So here we're saying basically, give each row a number and use the number 1 for each row. Now we're going to go ahead and total those rows by ARN, which is going to take all the ARNs and add them all up. So each user that logged in successfully, add them up. And now what we'll see is this user has logged in 50 times over the last 15 minutes. As well as if there were any other users that had logged in successfully during that time, they would show up here as well. But what we now want to do is we want to take our total and look for where it's greater than 1. Because if one user logged in successfully during this time, they would have a total of 1 next to their name. In this case, we're showing that, saying, show us where the total is greater than 1, or 2, or more. So now when we run this, we're going to see only those users that have logged in multiple times. And now this last portion of the query is just cleaning it up a little bit. It's just saying, get rid of the count and the row number. We don't really need to display them, so remove those fields. And now what I see is over the last 15 minutes, B. Smith has logged in 56 successful times from all these different IP addresses. And now this is where you would put your security hat on and say, you know, go talk to B. Smith. Why are you doing this? If he's doing some testing with VPNs, then it would make perfect sense why this might occur. If he's on vacation and not using his computer, well, this is going to be a little more suspicious. So once again, we can provide the data to you, but then what you do with that data is, you know, is your role, is your job to take that and do something with it that you think will be helpful. All right, great. So let's go ahead and look at lab 5. 5 and 6 go together, but they're worth going through, so we will do them. Yeah, let's go ahead and do them. So with lab 5, this is going to introduce the idea of surrounding messages, and actually the idea of log reducing to the same place. So let's go ahead and, yeah, this might be easier to show. Let's see if there's any questions. So the question is, can I add those top people who made high login failure to an active list or similar option for a focus monitoring? Yes, so what the individual is asking about is, can I take that list and list of people in this case and move it to another list and do something with it. And you can do so with lookup tables, where you can save your own lookup tables. And we'll actually go through an example of that in about 15 minutes or so. So good to see that you're thinking of that. You're on the right page. So lab 5, I'm going to go ahead and show the data and then do a log reduce. Let me show this. I think if you certainly want to go ahead and do it on your own, you're welcome to, but I think this will be better to show what you can do with this information, what this feature does. So what I did is I looked at the security data again. This time I'm more interested, instead of the IPs, I'm interested in these classifications. So here I have a classification of attempted information, classification of web app attack, classification of detection of network scan, all these security events that have taken place. And let me do the last hour of data, so just get a little more data in there. So what I now see is over the last hour, there have been 6,204 different security events. Now, what if I want to go ahead and get a very basic and quick understanding of what those events are? How many of each one were there? I could go ahead and create a query that says, look for classification, whatever's after that, create a field for classifications and do a count. And that would work, and absolutely would work. But an easier way to do this is to use the log reduce button. Because what the log reduce button is going to allow us, or you to do, is take that data and group it together based on patterns, and then display those patterns and show you those results. So now what I see is, of those 6,000 results, 3,000 log messages were attempted information leaks. 620 of them were sensitive data, and so on and so forth. So it gives me a good way to take my logs and reduce them down to these kind of bite-sized chunks of data that I can more easily glean what's going on. Now, what we want to show here in step 2 of Lab 5 is the idea that you can use or look at the surrounding messages of these messages or any messages. So what do I mean by that? Because that explanation was pretty poor. What I can do here is, for each one of these patterns that matched, I have a number. And what this number is telling me is that there were this many messages that matched the pattern. So for this one, there were 32 messages that matched this pattern. For this one, there were 1, and so on and so forth. If I click on the number, I'll use this one here as an example. When I click on the 1, it's going to then show me those log messages. So not the patterns themselves, but the log messages that match that pattern. And here I see this log message. So now I see the successful administrator privilege key. What I can do is I can start to look at the surrounding messages around this message, which may help give me some context into what was going on when this thing happened. So what I can do is I can go ahead and say, okay, show me the surrounding messages of plus or minus 1 minute, 5 minutes, or 10 minutes. And so what that's going to do is basically take the log message from 12:05 and look 1 minute before and 1 minute after and show me all those log messages. So I'll go ahead and do it. And now what I see is, or is it done? No, it's still doing it. Just another second. But it's going to take that log message that I just told it to use the surrounding messages for, and then show that here. So let's see, we should see the log message in blue right here. Hopefully you can see that it's in blue. And then we see the log messages 1 minute before and 1 minute after. And where this can be helpful is, as I was starting to describe, is in helping you see what was going on in your environment. Because let's say, and this is going to be a hypothetical, but I think you can kind of ride along with it. Let's say we saw a successful administrator privilege game. And 1 minute before, or 30 seconds before, we saw Bob log in. We saw Bob did something. We saw a successful administrator privilege gain, and then we saw Bob log out. Well, what was Bob doing in there that resulted in that successful administrator privilege gain? Was it something malicious? Was it not? But you can start to see through the surrounding messages what was going on and kind of help build a story that shows what was going on. So it's a helpful feature just to see what was going on around that message. Now, Lab 6 is going to introduce log compare, which you may have used before, but let's go ahead and go through it as well, because these are valuable features. So I'm going to go back to the first step, And actually, why don't you guys play with this for a minute? So Lab 6 has 4 steps to it. I'll give you like 2 minutes or so to leap into it, and then I'll go through some of those steps. So I'll give you a head start. But what we're going to do here is we're going to use log reduce and log compare. And log compare is like a subset of log reduce, but I'll digress. I'll pause and give you guys 2 minutes. All right, so let's start to go through this one. So the first step of Lab 1, 6-1, is just having us use the log reduce once again. So with that, we're going to take our snort data, and we'll do log reduce, and we're putting that data into those patterns, or doing the pattern matching with the data. Now, where log compare is going to be helpful is to look at a comparison of the log reduces over a different time period. So at this point, we have our last 60 minutes of data, and we know that there were 6,000 results, and that there were 3,000 messages related to attempted information, which sounds quite scary. Well, is that a lot or a little? I don't know. But what we can do is we can have the system start to tell us and compare with another time period. So when we click log compare, what we're doing is we're telling the system, do a log reduce of our data for the past 1 hour, so about 12 o'clock to 1 o'clock local time, and then go to yesterday from 12 o'clock to 1 o'clock local time and do the same log reduce, and then compare the results or show us the comparison of the results. And so now what I see here is for those classification of those attempted information leaks, well, we have a decrease by 2% from yesterday at this time period to today. So that's showing us, even though 3,000 might sound like a lot, it's actually less than yesterday. Conversely, there's been an increase by 1.1% of sensitive data, et cetera, et cetera. So it's a really nice way to start to compare time periods. If you don't want to do the last 24 hours, you don't have to. You can go ahead and customize this. So maybe comparing Monday to Tuesday doesn't really make sense. Maybe comparing Tuesday to Tuesday makes more sense. So we could do 7D, where we're saying, look at 12 to 1 o'clock today on Tuesday, and go back to last Tuesday from 12 to 1, and look at that information and then compare it. Now, we can also go ahead and look at the delta percentages here. So that's what this guy is right here. The delta percentage is showing the increase or the decrease from the other time period. But we can start to utilize that if we want to. So what we can do in lab, this is 6-3, is go ahead and say, only show us where the absolute value of that delta percentage is, say, greater than 25%. And by doing so, we're basically saying, ignore the increase by 2%, ignore the decrease by 0.84%. Just show us those things that are more meaningful in changes. And I have a typo in here somewhere. Let's see. Oh, forgot the delta percentage. Here's my typo. The parentheses. Thank you. Thanks, Jamie. Good call. That was a test. You passed. So now what I see is only those percentages that are greater than 25% or less than the absolute value of 25%. The other thing I see in here, which is helpful, is I see those messages that are new and or gone. And what this is telling me is yesterday at this time, there was not this type of message. Today there is, so this is new today. And then the opposite would be gone, where yesterday at this time there was that type of message and today there isn't. So you can start to see that. And what we can do in this last step of the lab is look for those that are just new. So we could say, just show us those things that is new. And now we would start to see just those things that are new today that did not exist yesterday. Now we'll use this portion of the query later to do an alert based on it, but we'll get to that. So good. Let's go ahead and lab 7, why don't you go ahead and play with for a moment as well. This is introducing outlier. Outlier is really going to be helpful in establishing a threshold based on variables or parameters, and then having the system help you understand when you fall in or out of that threshold. So I'll give you guys a moment to play with this query as well, and then I'll jump back in and discuss what it's doing in more detail. All right, so what are we doing here? So what we're trying to use is the lookup operator as well as the save operator to create our own lookup table or our own custom list of data. So what we're doing in the first couple steps is we want to define the data we want to save. So what the goal here is to create a list of blacklisted IP addresses, and we're going to populate the list with IP addresses that Snort has identified with a priority 1 alert. So we want to keep track of those. Those priority 1 alerts are important to us. So with the first line saying, look at the Snort period data and only look for those that have a priority 1. If it doesn't have priority 1, it's not relevant for today. We're then going to go ahead and start to grab the IP addresses from them. Now, as a reminder, with this regex, we're grabbing the first thing that we see that matches the number pattern. That is going to be an IP address. And so now we see that value displayed here. So we have our source IP over here. We're now going to take those IPs and just count them. So how many IPs do we have? Well, let's count them and see. So now we have a list of a lot of IPs. 25 times 14 pages. What we're going to do now is we're going to take this source IP column and we're just going to rename it. That's what this as is doing. It's basically saying create a new column with the source IP information, but call it blacklisted. So now when I run it, I see my new column called blacklisted. Now what we're going to do is we're just going to go ahead and get rid of that source IP field because we don't need it anymore. We have one that shows the IP as blacklisted now. So we're just going to clean things up a little bit. And now we're going to save the data. So we're going to save it to essentially wherever we want. And so I'm going to save it to this location. And I'm going to copy this just so I can look it up in a moment. So now when I click save, or start rather, excuse me, that file is being saved, or the data is being saved to a file. Now what we can do in step 2 is verify that that file is there. So we can go ahead and just do a cat. And then specify the file or the folder with the file location. When we do this, we should now see the data that we just included. And what did I do wrong? Let's see. Let's see. We can identify comments. Yep. Thank you very much. So what we're doing here, we're going to run this. I had my save, my last line, into anything. And now when we do the cat, we see that save file. So what we can do now is we can utilize this file and start to compare results to it. So in this case, it wants us to actually look at another file that we already saved. So we're going to look at the shared Snort alerts, just to verify it's there and look at it with the cat. We see those 5 IPs. And now what we could do with this last line, and I'm going to copy the last line, just I'm doing too many typos as is. Now with this last line here, or series of lines, we can now say, look at the Snort data, grab those IPs, and now compare that to a blacklisted list of IPs, and then show us only those places where the information is not empty. And so now what we're basically going to see are these are those IPs that have been deemed to be malicious or blacklisted, and we look them up. So the lookup table is very helpful. Strongly encourage you to use it. The one thing that you'll find, or actually not find, is at this point there's not really a good way to see what files have been saved as lookups. So when you save something, there's not really an index or a directory that you can go to view that information. You should have that, and we know that, and you will in the future. But just right now, there's not really a good way to see all the things you've saved or what other people in your organization have saved. So I wanted to give a little bit of a heads up. Not that big a deal, but certainly worth noting, I think. All right, cool. So this next portion here, I'm actually going to skip a couple of these labs here. 12, 13, and 14, I'm going to skip a little bit due to time. But these are helpful because what they're going to allow you to do is start to do correlation. So you can start to take a piece of data, something like a session ID, an IP address, and go ahead and take that and go ahead and start to see as it transverses through other parts of the system. So you can take an IP and see where it shows up here, see where it shows up there, and start to kind of follow it along and use that in multiple places. So these labs are good. I'm going to skip over them for right now, if that's okay. I'm also going to skip over lab 15 and 16, which is creating a public dashboard and adding panels to the dashboard. I feel like by now you've probably done that with us already. If I see like an overwhelming amount of people clamoring for it right now, we can go through it. But I feel like you've probably done that at least once before with Sumo Logic. If you haven't, it's a very important feature, but I feel it's a touch repetitive for today, so that's why I'm going to skip over it. But I don't see anybody really whining about it, so I think that's okay. But like I said, if you have not created a dashboard yet, please go through those labs. They're very important to do so. All right, so let's go ahead and lab 17 is a good one. It's actually something similar to what we did already, but it's going to allow us to utilize alert, which is going to be very helpful for you. Because what we've been doing so far is we've been using the query language to see things in Sumo Logic or see things in our environment really through Sumo Logic, but we haven't really created any notifications from that, any alert mechanisms. We've allowed you to create a query and run it, and then you see the results from that query, and then you would go ahead and do something. But we want to kind of try to bridge that gap a little bit and make it easier for you to go ahead and do. So I'm sorry, I'm just going ahead and giving someone a login here real fast. There we go. So what we're going to do here is go straight to step or lab 17-2. And so what we're going to do is do that time shift, do that log compare again, and do that even where it is new. So just as a reminder, we're going to take our source category of labs/snort data. And we're going to go ahead and do a log compare. And we can do a log compare right away. And a log compare is going to take a log reduce from 2 different time periods. So we don't have to do the log reduce first. We can just go straight to the log compare. Now with the log compare, as a reminder, it's showing us over the last 15 minutes. Here's what's happened today that's during this time period, this last 15 minutes. Here's what happened yesterday during that same time period of that 15 minutes, and then showing us the differences. But we're going to use the is new here because we want to see only those things that are new. While it's helpful to see that there have been attempted information leaks and all that, I want to know the next time a new security event gets flagged in the system. And so that's what this line is doing. Now, what this line is doing, though, is it's only showing me those things that are new today that did not exist yesterday, which is good. And in this case, it actually shows nothing new. Let's get a little more data here. There should be at least something new in there. Okay, perfect. So we see actually 3 of them. So that's really helpful to see that today, during this time period, these are new, and yesterday they did not exist. But I want to know about this not sitting in Sumo Logic. I don't want to have to click the start button every 5 minutes, every 15 minutes. The next time something's new, let me know. And so that's where you can turn this into an alert. So what you can do is you can go ahead and turn this into a scheduled search. So you could save this. So you would go to Save As, and you would go to Schedule this search on the bottom. And you should save it before you do a scheduled search, but you don't have to. So you should save it, save the query, but it's not required, which is kind of odd. So I'm going to choose to schedule this search. And then I'm going to decide how frequently do I want this search to run. Do I want to be notified in real time? Do I be notified every 15 minutes? And I'm going to choose real time. And now what's going to happen is next time there is an is new, meaning that there is a new event that occurred today that did not happen yesterday, I'm going to get a notification. And I can decide what type of notification I can get. So do I want to get an email? Do I want to integrate with ServiceNow and have a ticket, which is a ticketing system? Do I want to have a ticket created? Do I want to use webhooks so that I can send a Slack message or a Discord message or even a Twitter message? If I choose email, I can decide who I want to be notified. So you know what? Maybe I want my security team to be notified. And I didn't even spell that right. But you know, I can start to put email addresses in here of who I want to be notified. And then the next time that happens, they will get notified. Now the benefit there is they're going to get notified that a new security event has taken place, but they don't even have to log into Sumo Logic to know about that. They don't even have to know that Sumo Logic's around to know about that. They're going to get that alert, and then they will do, either go through their playbook or what have you, and do something about it. And so the alerts are a really great mechanism to, somewhat ironically, keep you out of Sumo Logic. Now, we're not trying to keep you out of Sumo Logic, but we want people to benefit from Sumo Logic that may not have access to it. And those alerts are a great way to do that. The other thing is it just prevents you or helps you from not having the query button all day. All right, cool. Lab 18, let's see. Lab 18 is worth going through. Why don't I give you a moment to play with it? And the reason why it's worth going through, I mean, all these are, but what this allows you to do is take a bunch of the things we've gone through today and create kind of a mega query out of them that will then allow you to start to take different pieces of information and use them to give you more context around them. So what this will have you do, and I'll give you a moment to play with it, but I'll just kind of set the table, is it's going to have you start to compare the amount or count of log messages that have 200, which would be a successful connection, versus 404s. So it's starting to compare good to bad. Because if I tell you that there have been 15 404s over the past hour, is that good or bad? I don't know, you need a little more information. And so you're going to start to use the query language to get those. So I'll go ahead and give you a few moments to play with this. It looks like there is a question. Let's see. Someone just needs help getting logged in. So go ahead and play with this query for Lab 18, and we'll go over it in, let's say, 2 or 3 minutes. All right, so let's talk about this lab and this query and what it's doing, because there's a lot going on, but a lot of good stuff going on. So I'm going to go line by line as I've been trying to do today. So with the first line, we're saying only look for those status codes that are equal to a 200 or 404. If it's not equal to 200 or 404 for today, we just don't care about it, because we want to compare those or start to look at those values. We're going to start to use a time slice. So we're going to do the last 60 minutes just to get a little more data. But we're going to say for the last 60 minutes of data, go ahead and let's look at the results at 1 o'clock, at 1:01, at 1:02, et cetera. That's what that time slice is doing. Now this next line, we haven't gone through this yet today, but it's a helpful little kind of computation. What this is going to do is when we run this line, we're going to be looking for the status code of 200. Or we're going to be looking for the status codes. If we find a status code of 200, we're going to consider that to be a success. And if we find a 200 and this statement is true, we're going to tally a 1 for a success. If we find a status code is not equal to 200, we're going to tally a 0 for a success. So let me go ahead and start this and show you what it looks like. So here I have my status codes, and here I have a column with successes and 1 in the success column. If I had a 404, or I just don't want to spend too much time looking for one, here's one, I would have a 0 for success because it's not 200. Now this next line is doing the same thing, but it's doing it for 404s, and we're going to create a column for fails. So the system's going to look at the status code. If the status code is equal to 404, we're going to tally a 1 for that to be true, or because it is true, and as a fail. And so now when I start this, we're going to have another column for fails. So here's a status code 200. Is that a success? Yep, so we have a 1. Is it a fail? No, and so we have a 0. Conversely, if I can find that 404 again, and there's a few of them in here. Here it is. Is that a fail? Yes, it is, and so we tally a 1. Is it a success? No, it's a 0. It's not because it's not 200, and so it's a 0. Now we're going to take those columns of successes and fails and add them all up and do it by time slice, so do it by those 1-minute increments. And now what we see is at 108, there were this many successes and this many fails, or this many 400, or this many 404s and this many 200s, or vice versa. At 128, this many. So we're starting to get something but we need more apples to apples. We have numbers, but how do we make it apples to apples? Well, we can establish a failure rate. Basically say, take the count, divide it by the other count, and that's going to give us a failure rate. And now that gives us something that we can start to compare. Because now I see at 108, the failure rate was 0.04, here is 0.043, so on and so forth. So I'm now getting numbers that I can start to compare. I'm going to sort them just to put them in time order. By default, when we use the time slice operator, they are in random order. I'm not really sure why, but they are. So we're just going to put them in descending order. And now we're going to use the outlier, because we're going to say take that failure rate and use the math and determine what an acceptable range is for those failure rates. So now the system is looking at the failure rates, looking at the previous ones, and starting to develop a range. So here the range is 0.03 to 0.05. The actual is 0.04, so that's within that range, and all is good. If we fast forward a little bit to 1240, we see the range is between 0.041 and 0.048. The actual is 0.051, which is outside that range, and so we see the indicator and the violation of 1. Now there's another way to look at this data. We can go ahead and use the chart option. Now if we choose the chart option, we see those outliers, but we can actually express this and change the axis and change it to a log scale just to get it formatted a little bit better. And so now what we see is over the last hour, there have been 3 times where the failure rate is greater than expected, which is bad. And so, we want to let somebody know. Now, this is good. We now know previously, like I said, over the past hour, these things have happened. But the goal here of this one is to create an alert with context. So we have context, but we don't have that alert yet. So we're going to go ahead and do two steps here to do so. The first is, we're going to go ahead and say, only show us those places where the failure rate violation is greater than 0 or 1. So essentially just show us those outliers. So when I run this now, I'm only going to see those outliers that have taken place over the past hour, and those are those 3 that I just alluded to. But we still need the alert component of this. We have the context, we got great information, but going forward, we want to start to create an alert where the next time the amount of 404, or essentially the failure rate is outside the range, we want to be notified. So this is good for the old information, but going forward, I want to get these alerts. And so to set this up, once again, I'll go to Save As. I'll choose to schedule the search. I'll decide how frequently I want this to run. And now the next time the condition is met, referring to the failure rate violation kind of going off, if you will, then I'm going to get an email. And then I can decide who do I want to get emails. Maybe I want my web dev team to get an email because we're getting more 404s than 200s, the failure rate is high, and somebody on the web team needs to know about it. Maybe there's an error in our code, maybe we just need to add more servers, whatever they need to do to fix it. But this allows me to notify them, and once again, they can get the benefit of Sumo logic without sitting in here creating queries all the time. The next time this bad thing happens, the failure rate is higher than expected, they'll get notified, and then they go do what they do. So really helpful query, and also has a bunch of different steps in here as far as different things we've either done today or operators you can use within Sumo logic. Now, the last thing I want to go over is, let's do Lab 20. And what Lab 20 is going to introduce is the idea of apps, which hopefully are not new to you. If they are, we'll go through them pretty quickly, but specifically related to the CrowdStrike data. So with Lab 20, we're going to go ahead and add a new application or a new app. So what we're going to do is we're going to go into the app catalog on the far left to the black bar, and we're going to go ahead and look for a particular app, and the app we're going to look for is Threat Intel Quick Analysis. So we can either just scroll through the list or just start to type threat, and we're going to want to choose this quick analysis one. What we're now going to do is tell the system where our data is, and then we're going to take these queries and dashboards that Sumo Logic has created, link them to the CrowdStrike data, and then link them to the data you want to examine. So that's kind of the three linkages that are going on here. And so we're going to add to library. We're going to give the app a name. Normally you can stick with this name, but you may want to put something, your initials, just to distinguish yours, but it doesn't really matter too much. And then we're going to tell the system what data we want to look at. So in this case, we're saying we want to look at our ELB data. We think, well, not even we think anything malicious is going on. We want to see, is anything malicious going on? Are there any bad actors? What does CrowdStrike think of our AWS ELB data by looking at the IPs and all that? So we're just saying, grab the data, grab the queries, grab the CrowdStrike data, put it all together. And when we do, we now have an app that's been created for us. Now that the app has been created for us, now we can utilize the app. So if we start with the Threat Intel Quick Analysis Overview, for example, this is taking our AWS ELB data and comparing it to the CrowdStrike database. And so now what I see is, over the last 15 minutes, there have been 2,800 log lines that were scanned for threats, and there were 1,000 IP threats, 1,300 URL threats, and all this information. Now this is lab data, so the numbers may be a little high or out of whack, but that's why. I can then go a little bit deeper. So I can go to the quick analysis and say that I specifically want to look at, I don't know, domain information. The system's going to take that ELB data, take that CrowdStrike database, look at the domains, and now start to give us information about them. And now what we see here in this threat table is over the past 15 minutes, data has come from these 5 IPs that are considered, or excuse me, these 4 domains that are considered malicious confidence of high, and we would probably want to know about. And then once again, now we put on our security hat, and maybe we block them, maybe we monitor them through the system and see what they're doing. But ultimately, we need to decide what to do with that data. We can give it to you, but then you need to take an action with it, or not, but at least then you decide what to do with it. So any questions about what we covered today? From a lab standpoint, that's really what I wanted to go over. So I think we hit everything. The couple that we skipped, like I said, I just encourage you to get at a later time. Okay, so no questions yet, which is good. So what we're going to do now is we're going to take the exam. To take the exam, you're going to want to make sure that you log out of the training account that we were just using and log back in with your corporate or your personal Sumo Logic account. And you're going to want to go to Home and go to Certification. Once you do, you'll be on this screen, and you'll take the exam. The prep we did was the webinar, which is me doing the labs. The hands-on labs was you doing the labs. So you kind of did the prep there. The exam's going to be 30 questions, 60 minutes you'll have. It's open book, open resource, open Google. So if you want to use our documentation, if you want to use the app itself, however you need to get help, feel free to use those. And then once you're done and pass, you'll then be a Sumo Security Power user. You'll get a little certificate. You can put your information in LinkedIn, and you've now learned a new skill that's starting to become more popular in the job market. So you picked up something today. And that really kind of concludes what I want to go over today. So I'm going to go ahead and leave this bridge line open for about the next hour or so. I encourage you to take the exam right now, and if you have any questions, let me know. And then once you're done, just go ahead and hang up and enjoy the rest of your day. So thank you for attending today. We will follow up taking out the slides, although we really didn't use too many slides today, but I'll send out the deck anyhow, and I'll send a recording out of this as well, so you can either use it or share it with whomever. So yeah, why don't you go take the exam and just give a shout if you have any questions. So once again, thank you for joining, and hope you learned a little something today of how Sumo can be used in that security use case. So thank you, and I'm going to put myself on mute, but I will be here.